quick video about transformers then. Transformers, you need to know they are made out of a laminated soft iron core. Laminated means it's in little strips. This is the primary side of the transformer. This is the secondary. You need to be able to identify them when you work with the maths a little bit later. Primary needs to have an alternating current. That alternating current produces a changing magnetic field, so the north and the south on this transformer change, and that produces an alternating voltage across here. Okay, there is no current passing from the primary side to the secondary side. A lot of people don't really get that. It does look, when you're using them, like there's current coming through there. Okay, so you need to know as well the difference between a step-up transformer and a step-down. So this is going to be a step-up. And you need to be able to apply this equation here. This is the transformer equation. Vp is the voltage on the primary, so the voltage between here and here. That's Vp. Vs is the voltage on the secondary, the voltage between here and here. And the number of Np is the number of turns on the primary. So let's just go round this side with a piece of wire 5 times. That would mean Np would be 5. And if I want a step-up transformer, I need to have more on the secondary. So I'm going to loop the secondary wire around the transformer 10 times. Okay, so the equation is Vp over Vs equals 5 divided by 10. Now what that means is, if I put in, let's say, 2 volts here on the primary side, well, Vs is going to be double that, isn't it? It's the same as the ratio of that. So we can work that out if you like, just by doing this is 0.5, 2 over Vs equals 0.5. So Vs would equal 2 over 0.5. Okay? Do that in the calculator. Yep, that gives you 4. So the voltage out, the voltage produced by this step-up transformer would be 4 volts. So step-up transformer has fewer turns on the primary, more on the secondary. The turns step up, so the voltage steps up. So what is a step-down transformer? Well, maybe you've guessed. A step-down transformer actually reduces the voltage. So this time I'm going to do 20 turns on my primary. Okay, and on my secondary I'm just going to do 5. This is a wire looped around which is producing that changing magnetic field. Now if I'm going to put in 20 volts here on the primary. I've got 20 turns here, so 20 Vp. Vs is what we're going to calculate. I had 20 turns on the primary and 5 on the secondary. Well, without doing the maths even there, I'm sure you can figure out that Vs has got to be 5 volts out as well. So a step-down transformer reduces the voltage. A step-up transformer increases the voltage. Next we need to go on to explain how the voltage influences the current. So these two equations, this first one, the transformer equation, and this second one, which we call the power equation, really the same kind of thing. You're always going to be told kind of 3 out of the 4 of these values, and you just have to work out the fourth one. It's not really all that difficult. This is called the power equation because electrical power is current times voltage. And what we say is the power on the primary side is going to be equal to the power on the secondary side. So these two values are the same. And that allows us to work out the third unknown. It's the same idea. You're working with ratios, you're working with products here. So let's talk about, well, a situation we're taking something like a 12 volt, and we're going to step that up to mains electricity. So we want our VS to be 240 volts, and we're going to get a current of about an amp, let's say, out of our 12 volt battery there, 1 amp. What's the current going to be in our stepped up secondary circuit here then? Well, we just simply plug the numbers in there. So 12 times 1 equals 240 times the current on the secondary, IS. So rearranging, you just do the inverse operations in this case. So times 240 becomes divide by 240. 12 times 1 is 12. So 12 divided by 240 equals, go for the calculator, 0.05 amps. So, you know, that's a really small current, and that would be a problem if you were trying to run a mains electricity thing off a battery. You stepped up to the right voltage, but you wouldn't have a very high current. But actually, in the national grid, we make use of that. When you step up the voltage, you reduce the current very much. We make use of that because it reduces, and it significantly reduces our power losses in the cables, and that's really important for a high efficiency power transfer. So if this is the power coming out of our power station, this is going to be somewhere in the region of 20,000 volts. This is our step up transformer. It's going to increase the current to somewhere around the region of 400,000 volts. Sorry, it's going to increase the voltage somewhere in the region around 400,000 volts. That's going to reduce the current hugely in the power lines here, and that means we get a low power loss. Then this is the step down transformer, which reduces the voltage down to 230 volts for consumer usage. So why do we need to reduce that current so much? Well, it's because of this equation here, which if you need to use it, you'll be given it. It's the power loss is the current squared times the resistance. So the resistance doesn't change with these power cables. Because we've stepped up the voltage, we bring down the current. So here, the current is very low in the power cables there. So power loss is current squared times by the resistance. So the higher the current is, you get much more power loss because it's not just multiplying by R, it's actually being squared first. So if I had twice the current, I'd have 4 times the power loss, and if I had 3 times the current, I'd have 9 times the power loss. Okay, so when we're trying to transmit the energy, the electrical energy over large distances, we try and reduce the current as much as possible. But then we want to actually step down the voltage because our appliances, they need a higher current. They need to use that current to do their work. So we have to actually step down the voltage to therefore increase the current afterwards. I really hope that helped you guys.